Hey there, Algebra Half. I talked about math and algebra last year with the students, almost like it's an English class or a language class, because algebra is like a language class for math, where you learn ways to show a sentence that can be said in words, but instead using numbers and symbols. And if you've ever asked, like, why do we say algebra now and we don't call this math class? And I always think about the equations and the variables and the rules that we learn that allow us to isolate a variable and solve, right? Getting x by itself, things like that. And that's really what this phrase from page number 269 is attempting to say. Algebra is, read the italics as I go, the art of expressing problems with symbols and solving by working with the symbols according to rules. Okay? And that makes you think about the equations and the commutative properties, and the lesson 88 is going to talk, 87 is going to talk more about different properties like the associative property, the reflexive, the symmetric, and even the transitive properties, all different things that we have to follow so we don't break the rules and get the wrong answers. Now, when we write these equations where I think of like a value set equal to another value, we use what's called algebraic phrases. So all of these are like word sentences that we could use in English class. The sum of a number and 7 is something, right? That looks like English. Now we can change it into the language we call algebra. Algebra is like a language using not the characters A, B, and C as much as variables that stand for quantities and numbers and symbols like plus and minus and ratios. And so we can translate this language into our math language we call algebra. The sum of a number, well, sum, we've learned some vocabulary in this language already to know that sum means this symbol. We're going to be finding two things joined by that symbol, plus sign. The sum of a number and 7. So 7's easy. How do we show a number? The book is going to use a variable, and we're going to try n for now, yn, because that's the same as the letter that number starts with. But it could be any number or variable. It could be x, right? We could use the letter x for a symbol. And if we want to translate this one here, 7 greater than a number, greater than is going to be another thing where we know, okay, that sounds like plus, greater than. Don't use the greater than sign because we don't use those in equations. We're going to say 7 greater than a number would be like 7 plus the number, or x, we could also show that as x plus 7. Okay, how about a number increased by 7? I'm going to do this one in blue. A number increased by is, again, sounds like addition. So it's just another way to show this. N plus 7. 7, how about less than a number? Let's go in the order left to right. 7 less than a number, we can't go 7 minus the number because now it's a number less than 7. If you think about, if I put 7 and then I think less than, like a minus, and I go a number, if I fill this in, you can always test this. If I fill this in with a 5, is this going to be 7 less than that number 5? No, it's going to be 5 less than 7. So we gotta flip that around, right? Use easy numbers to think about these sometimes and make sure you're doing it right. Instead, let's flip that around and put our number first. 7 less than that number. Okay? How about the product? We know what operation goes with product. What symbol? We think of this symbol, or maybe parentheses. And the product of a number and 7, right? N times 7. How about twice a number? Twice, 2 times. And we put that right next to a number. That's usually how the book wants to show that. This implies multiplication. 9 times the opposite of a number. 9 times, okay? Now what should go inside getting multiplied? Opposite of a number, opposite of. Here's our most complicated one yet. 5 times the sum of twice a number and -8. Let's go left to right. 5 times what? The sum of twice a number, which we learned over here. Let's see if I can fit that in here. Try that again. Didn't give myself a lot of room. Twice a number plus -8. Now that sum is really a minus problem. I'm going to put this again up here. 5 times the sum of twice a number and -8 really ends up being this. Make sure you use that parentheses so that this gets properly distributed, right? That comes out to 10n minus 40. Oh, minus 40, right? Okay, I'm going to clear out some of this stuff so we have a little more room for this practice problem. And if you wanted some of this stored for you in your notes, this was all said along with extras on 269 and 270. In fact, you can even do a little exercise to see how well you're doing. It says cover the answers. You see where that says cover the answers on the right hand. See if you can write, translate into algebra language those phrases without the help of the book. See how well you can do. You can use n for your variable. You can use anything, x, y, z, doesn't matter. But make sure you're using the grouping symbols the way they show and have all the signs correct. It's going to take practice. Let's try writing the algebraic phrase for a number reduced by 4. How do I show a number? Let's try y this time. Doesn't matter what letter. Reduced by operation minus what quantity? 4. So y or x or whatever minus 4. We could test this, put something in for y like 5. What's 5 minus 4? 1. Does that make sense? A number reduced by 4, 5 reduced by 4 would come out to 1. Why don't you do A and C, please, to your very best. Thank you.